Hello, everyone. It's great to be here. My name is Jan-FelixSchmakeit, and I'm a developer programs engineer on the Android team. I'm actually visiting from Sydney. Let's see, there you go, Jan-FelixSchmakeit. So I'm here to tell you a little bit about some of our security improvements that we have made over the last few months, and I will talk a little bit about some of the improvements we've made on the Android platform over the last few releases as well. And then finally, a few interesting APIs that you may not actually have heard about just yet. So, to kind of get started, I would like to talk about Google Play Protect. And Google Play Protect is an effort that we launched a few months ago at Google I/O, and it's an effort from Google to keep users' phones more secure and make some of these security improvements more visible to our users. So, what is Google Play Protect? At its core, it's an engine that we have built over several years that protects all devices on the Android ecosystem. And what this means is that we are continuously scanning Android applications on Google Play and out there on the internet to make sure we detect any malicious applications or any applications that may have malicious behavior. So this entire system protects over 2 billion devices worldwide, and that's an amazing number, isn't it? This is growing year on year. So right now, we're doing over 1 billion device scans every day, checking over 50 billion applications every day. So that really is an incredible scale. And to do all of that, we have to rely at Google's power. So we have some interesting numbers here is, for example, that we're using over 20,000 dedicated processors in our data centers that are running 24/7. And these processors are analyzing all these applications, they're running them, they're testing them to see if there is any malicious behavior out there in those applications. So we're looking at the application data, we're analyzing it, and we're diving deep into every application that we find. And another cool number is that we are, every day we are analyzing over 500,000 new applications that we haven't seen before. So we want to really understand what all these applications do out there in the real world and what they're doing in our environment as well. So of course, the main aim of all of this is really that we want to protect our users. What we really want to do is we want to keep an eye out for any risks that our users may be exposed to, and we try to mitigate them before anything bad can happen. So to do all of this, we have built Google Play Protect. And Google Play Protect is built into any Android device with Google Play, and we are always updating it with the latest improvements from Google. So all these application scans that are happening every day, they're also making sure that your devices are secure. So Google Play Protect consists of kind of 3 main pillars, I would say. The first one is, as I've said, we are relying heavily on machine learning and our security infrastructure to have, basically built the world's largest antivirus system. We've expanded our security tools to give our users more ways to stay safe and secure and to take control of their own security. And as part of all of this, we've increased the visibility of all of these features, because many of these things that I've talked about are actually things we have been doing for many years. But now we're being a bit more public about this, and we're telling the users about the many different ways that we are keeping them secure and protecting them so you're always protected. So, at the key of all of this, at the heart, is machine learning. You've probably heard a lot about the advancements that Google and other companies have made recently in machine learning and artificial intelligence. And for us, this also stands at the core of our security efforts. We are using our inputs, so manual users, and together with machines to scale up to these billions of device scans every day. So we have really learned over the years how we can harness the power of machines to help us to keep our devices secure. This graph here, just in case you're curious, actually shows a cluster of a few different potentially harmful applications that have shown harmful behavior out there in the wild. So we're using these systems to make some of these decisions for us, so you don't have to worry about this as a user, using our technology for your benefit. You may remember a tool called the Android Device Manager, which we launched a few years ago. We have now launched a new service called Find My Device. And it's basically a very simple way to expose an existing technology and make it more accessible for our users. We've added some new technology as well. You can now track your battery status, your Wi-Fi status, and a few other details as well, simply through the Find My Device feature. It's integrated into Google Search, so you can simply type in, where's my device, and it should come up. One of the most common security risks that the average user is exposed to is really losing their device. Whether you're leaving it behind somewhere or whether somebody has taken your device. So with the Find My Device feature, it's a little bit easier for our users to kind of stay on top of this potential security risk. Lastly, the other effort that we have is to kind of raise the visibility of all of these security efforts and tell our users a little bit more about it. So users can be more confident when they're using our services. So as you all know, as application developers, every application that you find on Google Play goes through a rigorous screening process. And we have now added this as well to the Google Play Store to make it visible to the users so they understand that every application on the Play Store has been vetted and analyzed. So when you're setting up an application, we're uploading it, and we're actually checking it every day to make sure that there's no potentially new harmful behavior that has come up. So really, we're simply making it a lot more visible, and a lot of this work has really been going on for quite a while. And visible to both consumers and to enterprises as well. So as part of this, we've, of course, added an API, because as developers, you want to take advantage of this as well. So we've added an API, which we're calling the Verify Apps API. And this allows you to check the state of the device. So you can see if the Verify Apps feature is enabled on the device, so if the device is scanning all the applications in the background. And if it's not enabled, you can prompt the user to turn it on. Then, as a developer, you can then query to see if there are any harmful applications potentially installed on the device. So you can then make a decision whether your application should run or whether you should warn the user or degrade your functionality in some way. Finally, there's also the Safety Net Attestation API. And this is basically, this allows you as a developer to find out whether the device is secure and protected. So in Google's understanding of the device, is it secure and is it verified? This is really critical for applications such as banking apps, online shopping apps, and so on, where you want to make sure that the device your application is running on can be trusted and has been verified. So here, this API allows you to verify that your application is running on a secure, real device that has been verified by us and has passed all compatibility tests, and it hasn't been tampered with. The way this works is that when you call this API, the system sends some data to Google's server. We verify the state of the software on the device, and as a developer, you get back this response from Google's server, and it's signed with one of our keys, so you can be sure that it is, in fact, a real device and has been verified by us. And we're using this for things like Android Pay, where we have to make sure that we are actually running on a real, compatible device in a real operating environment. So as a developer, if you want to take advantage of this, just make sure that you're using this as an additional input into your existing abuse system. Don't rely on SafetyNet alone. If you're curious about this, we have some great documentation and sample code out there where you can try this out. And the reCAPTCHA API is an API that we launched fairly recently as part of Google Play Services, and not too many people have heard about it yet. You may remember reCAPTCHA from the internet, where you are prompted to verify that you are actually a human and not a robot. And this API is now available on Android as well. So this API allows you to verify that the entity interacting with your application is in fact a human and not a robot or a bot farm or something similar. So if you are offering a free service in your application, you have a limited free tier available, for example, you can use this API to make sure that only real users can take advantage of it and it isn't abused. This is a great feature that we had it in Android O. It's the Install Unknown Apps feature. If you've ever tried to install an APK from other sources, you have had to give blanket approval to all APKs to be installed on the device through the developer settings. Now we have a way to grant trust to other sources of applications. So if there's another store or if there's another source of applications that where you want to install applications from, you can now grant access to those as well. So there's a new permission, the unknown as the install apps permission, that you can add to your application, and your application will come up here on the sidelines. So this really comes from a bigger understanding of the Android ecosystem, because we know that users trust other sources of applications as well. Google Play obviously is a great source of that, but there are other sources out there as well. So this makes it a bit easier and a lot more safer for users to install applications. So let's talk a little bit about the Android operating system and some of the changes that we have made there over the last few years. Verified boot, let's start with that at the very beginning. Verified boot is Android's secure boot system, where we verify the signature of every component at startup time. So you can be sure that the operating system hasn't been tampered with. On Android M, we enabled it for compatible devices. In Android N, for Nougat, we strictly enforced it. And in Android O, we added some additional features around rollback protection, so you can't go back to a previous Android version where there were any known security issues. And we added some additional guidance around hardened unlocking. So the user now has to explicitly unlock the bootloader, which can no longer be triggered through software or through the operating system. And as developers, you will be pleased to hear that you can query the state of the verified boot feature as well. You can use key attestation for this, and I will talk about that in a little bit. So verified boot is about the operating system, protecting the operating system. Encryption is about protecting the user data. And again, here we have come a long way, starting with Android M, where we added encryption for compatible devices. In Nougat, we added a great feature called file-based encryption. And file-based encryption basically allows the operating system to encrypt different parts of the OS and different parts of applications with different keys. So some applications can actually run before the entire system is unlocked. And this feature is called direct boot. Definitely check it out if you haven't heard of it just yet. And in O, we added some additional enhancements to this feature as well. The lock screen really is trying to strike a balance between keeping it convenient and making it more secure, right? Because we want to make sure that if somebody accidentally takes your device, they can't access your data. So in Marshmallow, we added fingerprint support in hardware. In Nougat, we added PIN verification in hardware as well. And then in Android O, we added support for tamper-resistant hardware. So physical attacks against Android device are now much, much harder. This is quite similar to the chip that you have on a credit card, where physical attacks are really, really hard to do. So it's much harder to bypass the lock screen on an Android device. So encryption and the lock screen are about protecting the user data. Permissions really are there to control access to application data and sensitive sensors and data and so on. So the biggest change that I'm sure you are all aware of has been the addition of runtime permissions in Android Marshmallow. In Android N and in Android O, we have taken a step back and we have looked at some of the APIs and some of the permissions that we have seen abuse in. So ransomware and malware has used some APIs to use the system in ways where it shouldn't be used, as they have been abusing it. So we have made some changes to this as well. So first of all, as developers, make sure to check out our permissions best practices to kind of get you started with this. Really follow those best practices in your applications. And one of the key messages I have is make sure you fail gracefully, so if the user hasn't granted your permission, and make sure to request permissions in context, so the user knows why you need that particular permission. So in Android O, a few changes, like I said, we have descoped the system alert window and device admin permissions. So if you're using a system alert permission to draw on top of other applications, there have been a few changes. First of all, you can no longer draw on top of any system UI elements. This includes the system navigation bar, the notification shade, and the settings, and any other dialogues that the system may pop up. And the user now gets a notification to say that your application is drawing on top of other applications. We have also descoped the device admin permission to make sure that applications can no longer be prevented from being uninstalled, and they can't change the unlock code on the device. Another key change in Android has been the addition of some new privacy controls on Android. One of the big changes here has been that we have removed access to persistent identifiers on the device. So if you have used the Android ID to identify your users, it is now sandboxed per application and per device. And if you are using the net.hostname to get the host name of a device, this string is now empty for application developers. If you're curious about this, make sure to check out our blog post that we published. And if you're using instant apps, you've probably heard a lot about instant apps, but it's a way for you to run components of your application without being installed on the system. We have built permissions, security, and privacy controls, best practices right into the entire instant apps model. So any changes that you're making for instant apps obviously also benefit your normal Android application users as well. And at the heart of Android security really stands sandboxing and isolation. We have always relied on SE Linux to separate the different applications and components of the system, from each other. In NuGet, we started to break some of those bigger components of the operating system apart, starting with the media server. And in Android O, we've taken this a step further with Project Treble. And Project Treble is a way to separate the vendor implementation from the operating system and the framework. The way we are doing this is that we have defined a vendor interface that sits between the operating system and the vendor. And this vendor interface doesn't change. It stays static across all versions of Android. So the idea is that if there's a new version of the framework or a new version of the operating system, you simply have to swap in the OS or framework box here, and you can leave the vendor implementation untouched, because the vendor interface that divides the two hasn't changed. Of course, for security, that has some great implications as well. First of all, by having the static vendor interface, it's much, much easier for OEMs and manufacturers to update to the latest version of Android, which is great for our users, because it means that users are getting security updates much, much quicker. This also means that we have separated these two things away from each other. So an issue in the kernel or in the vendor implementation, the drivers, does not necessarily mean that the Android operating system, the framework, is influenced by that as well. So this separation is also great for security. So as you have heard, there have been a lot of changes around Android security and the framework and the operating system. And we are really working hard to make sure we are keeping the needle up there and we are always improving our security. Let's talk a little bit about some of the changes for application developers and around app security, including some new APIs that we have added. First of all, handling untrusted content in web views. So web views, a little bit of history here, have been an interesting topic. In KitKat and before, the web view was part of the operating system. So it was actually shipped as part of the operating system. So updating the web view meant updating the entire operating system. In Lollipop, we separated the web view out of the operating system. So we were now able to update it through the Play Store and push updates to our users out there. And now, in Android O, we have taken this a step further again. Here, we are now separating the rendering processes from your application. So if you're using a web view and the web view rendering process is compromised in some way, this doesn't mean that your application process is compromised as well. And we have also added a great new API called Safe Browsing. You may have seen this screen before. Safe Browsing is available in many browsers, particularly on the desktop. And basically, it pops up a warning message if you're trying to access a website that has anything malicious on it, a bad website, if you're following a bad link. So we have now added the support to the web view in the Play Store APK as well. And because we're pushing the update to the Play Store, this is now available on all devices running Lollipop and above as well. if you want to take advantage of this, it's as simple as adding an extra metadata to your Android manifest to enable this feature. So we've talked a lot about the different ways we have been working on the operating system and the hardware and the applications. But one feature, obviously, is also user and device authentication. So you want to make sure that your application and your services are talking to the right people, are talking to who they say they are talking to. So if you want to authenticate the device, you can use the Key Store API for this. The Key Store API allows you to generate a certificate pair. So you can use that certificate pair to identify a particular device in your communications. And because the key store can be backed by hardware on compatible devices, you can be sure that it can't be cloned or tampered with. It basically means that the key can't be extracted or cloned. Key store attestation is something that I talked a little bit about before. Key store attestation is a new feature we have added in Android O, and it allows you to find out some details about the Key Store API and the security of the device that the application is running on. So basically, your application, and by extension your service, can talk directly to the secure element on the Android device. And basically what you can say is, how is this key protected? Is verified boot enabled? So if you're using the Key Store API, you can ask the API to attest the key, and you get a signed response back. And the response is actually signed with Google's certificate. So you can verify the certificate to make sure that is in fact coming from a valid device that's following all of our standards and is in fact valid. And I'm also really pleased that we have now added some additional APIs around two-factor authentication. As I'm sure you all know, relying on a username and password these days simply isn't enough to keep your users secure. Two-factor authentication is really what you should be looking at as well. So we have now added APIs for FIDO U2F security keys to Google Play services. So you can use security keys that support NFC and Bluetooth to lock your users in as well. And we are very happy that this is now available on Android. So this was a whirlwind tour through all the different new announcements that we have made at Google I/O and over the last few months around Android and Google Play services. Of course, there are many other new features that I didn't get the chance to talk about. But if you have any other questions, be sure to catch me afterwards. So to get everyone started here, because you're all developers, definitely check out the security checklist and the security best practices. This is a great way for you to kind of get started, to think about security, and make sure you're following all of our best practices and our guidance around all of our APIs. And at Google I/O, we also released 2 new code labs, one around the network security configuration and one around storage and permissions, where you can try out some of the security features and you can see how an application behaves differently under different conditions. So definitely check these out as well. And with that, thank you very much. I will be out in the Ask a Speaker zone afterwards, so if you do have any questions, feel free to come by and ask me. Thank you.